Hi, welcome to Such Study Tech. Today topic is performance analysis. So what is meant by performance analysis? Here the previous video I discussed about what is the difference between posteriori and priori estimates. Now here it means deals with the time and space analysis for the algorithm. First you can see the space complexity, later you can discuss about time complexity. Now what is the space complexity? So it is the amount of memory it needs to run to completion of that program. So that is the space complexity. So this is the definition of the space complexity, simple definition. Now we can see the space needed is a sum of two components. Those components are fixed part and variable part. These are the two parts is there, fixed part and variable part. Here the fixed part is the independent of input. Okay, it is not depending on any input and output characteristics. It includes the like examples is instruction space and a space for the variable and a space for the constant and so on. So these are the fixed part. Now we can see the variable part is it is dependent on the particular problem instance. It includes the space needed by the referenced variable, like here it is a recursion stack space and so on. Here it is a variable part. Now let P be the algorithm, let S of P be the space requirement for the algorithm. Then this is the formula S of P equal to C plus SP. So what is the C? It is a C is a fixed space. C is a constant space, fixed space. So SP is the variable space. SP is the variable space. Okay, now we can see the one example here. Now there are two types of space complexity. One is the constant space complexity. So constant space complexity is a fixed amount of space for the all the inputs. For example, here you can see int square of int a. So this is the one algorithm. A return a into a. So here it has there is no variable part. So here the constant part is there. That is the constant part is here have the only one variable. So here the constant, this is the a is the constant value. Now we can see S of P is 1. So here it can represented the big of 1. So it is a constant type, constant space complexity of this particular algorithm. So here algorithm requires fixed amount of space for the all the input value. Here also, for example, if you want to perform, for example, sum of two variables like sum a and b. For example, here that there are two variables is there, two variables. Now we can see this is the algorithm. So sum of a comma b. For example, a value is there and a value is 10. Now the b value is there, b equal to, for example, 20. Now we can see the c equal to a plus b. So this is the algorithm, sum of two numbers a plus b. So what is the time complexity of this algorithm here? Here this algorithm consisting of three variables a, b, c. So here it can take the 1 unit of space. Here it can take 1 unit of space. Here also it can take the 1 unit of space. Here also it takes the 1 unit of space. Total 3 unit of space. So here it can write big of 3. But here it is a constant space. So that's why I can write big of 1. So this is the space complexity of this particular algorithm. Now we can see the linear space complexity. Linear space complexity second type. Here this space needed for the algorithm is based on the size. Now we can see here this is the algorithm sum. This is the here it is the array and size of the array, and here the sum and I variable. Here the looping statement is there. Here sum equal to sum plus a of I return some value. So sum of numbers from that array. So here for example, here how many variables is there? So here it is a sum variable is there, sum variable, and I variable is there, and also n variable is there. So sum variable it takes 1 unit of space. Here the I variable is it takes 1 unit of space, and n variable is also take 1 unit of space. But here the array is consisting of size n. So in array this array based on the, it is depending on the n variable size of the array. So here it takes the space is n. So now what is the time complexity, space complexity of this algorithm? Linear space complexity. Now S of p equal to c plus sp. So c is the constant, that is you can add this 1 plus 1 plus 1, that is 3. This is the constant space. Now you can see next one is the, that is based on the size. Here it is a variable space, like here it is n. So the total space is 3 plus n. Now what is the higher order? Here the function is 1. So here it can represented big of 1. The space complexity of this particular algorithm, that is big of n. Now next one is the time complexity. How we can calculate the time? So it is the amount of computer time it needs to run to completion. Time complexity is calculated as Tp equal to c plus Tp, where Tp is the time complexity of the algorithm p, c is the compile time, and Tp is the run time. Now you can see here also constant time complexity, it takes the constant time. So the time complexity of this particular algorithm is big of 1. Next one is linear time complexity. If the input values are increased, then the time complexity will changes. Now the comments, if any algorithm consisting of comments, it takes the 0 time. Here it is assignment statement, it is a 1 unit of time. Here the conditional statement, it takes 1 unit of time, and looping conditions for n times, that is n plus 1 steps. Like the body of the loop, it takes the n time. For example, here it can see, for example, this is the one for loop. This for loop consisting, for example, here I equal to 0, and how many times this statement is executed? I less than n, next I plus plus. So this is the for loop. This is the simple for loop. So for example, if you want to print hi, how many times this message is printed? Now you can see how many times this message is printed. Here it can check the n plus 1 times. It can check the n plus 1 times. The looping statement, it can check the n plus 1 times here, but the body of the loop, it takes n times. So you can see, for example, n value is 5, n equal to 5. Now n equal to 5. So I equal to 0 initially, I less than n, that is 0 less than 5. So the condition is true, then I plus plus. Now you can see, so I is printed 1 time, and also I value is 1. Here the second I value is 1. Now it can printed the second time, and I value is 2. It can printed the third time. I value is 3. It can printed the fourth time. I value is 4. It can printed the fifth time. But I value is 5. So the 5 less than 5, the condition is fail. But in that time also it can check that for loop. So n plus 1 times this for loop is checked, and n times the body of the loop is executed. So here the time complexity of this particular algorithm is big of n. In simple statement here, big of n. Now you can see the this is the example algorithm. So you can calculate the time complexity of this particular algorithm. You know already the header of the algorithm, it takes the 0, step count is 0. Here it is curly braces, it is also 0. It is a one statement, it takes 1. Here the looping, it takes 1. Here also one statement, it takes 1, and the return, it takes 1. So here the last one is curly braces, it takes 0. Now the frequency, can check the frequency, how many times this statement is executed? Only 1 time, that is 1. How many times this condition, this for loop is checked the condition? N plus 1 times. And also how many times this statement is executed? n times. Already I discussed that point. Now how many times this statement is executed? Only one time. So 1 into 1, here the 1 into n plus 1, it is n plus 1 here, 1 into n, that is n, 1 into 1, that is 1. So here this 0. The total is 1 plus 1 plus 1, that is 3, n plus n, that is 2n, 2n plus 3. So the time complexity of this particular algorithm is big of n, big of n. So 3 is the constant, you can ignore that constant values. Here also 2 is also a constant value, you can ignore it. So the time complexity of this particular algorithm is big of n. So you can see the one more example. The count equal to 0, here it takes the 1 unit of time. Here it is also, here I equal to n, I greater than 0, I by 2, j equal to 0, j less than I, j plus plus, count plus plus. Now for example, n value is 6. I am consider n value is 6. How many times this for loop is, check the condition, and how many times this inner loop is executed. This is the outer loop, this is the outer loop, here it is inner loop. How many times this inner loop is executed? For example, n value is 6. N value is 6. Now you can check the condition. 6 greater than 0. The condition is true. Now we can execute the inner for loop. Inner for loop. How many times is executed inner for loop? J equal to 0 to j less than I value is 6. J less than 6. So this count plus plus. This count plus plus. This statement is executed n times. Next iteration, here the inner loop is terminated and n value is, so that is I equal to n, so n by 2, so that next value is n by 2, that is n value is 3 now. So this statement is executed here n by 2 times. Next again here n by 4 times. Like that this statement is executed n plus n by 2 plus n by 4 plus and so on. So these are the times this statement is executed. Now it can write this statement in, simplify this equation. So you can take the n common here, 1 plus 1 by 2 plus 1 by 4 plus and so on. Now it is in GP, geometric progression. So what is the formula here? S of, for example, here the geometric progression, the formula is A by 1 minus R. So what is the A? A is the first term. What is the first term? 1. So that is equals to 1 by 1 minus, what is the R? Difference between the first term and second term. So here it is 1, here it is 1 by 2. So half is different. Here is also 1 by 2. Here is next third term is 1 by 4. Here is also half difference. 1 by 2 is different. So R is the 1 by 2. Now we can simplify this one. 1 by 2 into 1. 2 minus 1, that is 1 by 2. So what is the value here? It is 2. So n into 2. The value of this equation is 2. Now it is 2n. So 2 is the constant. So we can consider the time complexity of this particular algorithm is big of n. Now you can also check, for example, if you know that so you can see this is the simple program. Here the int is n, count equal to 0, and print, enter the n value, and you can read that value, you can store that value in n variable. And also here I equal to n and I greater than 0, I by 2. So j equal to 0, j less than I, j plus plus, count plus plus. Now how many times the count is executed? Now you can print that count. So this is the example program. So for example, here the n value is 6. So the count is 10. The count is 10. So that is the first. You can see here the exact time, that is the posteriori analysis, it takes the time is 3.8 seconds. Okay, 3.8 milliseconds. But here in priori analysis, so the calculate the time complexity, here it can see, so n plus n by 2 plus and so on. For example, here it can take the 6. Next, first one is it can execute the 6 times. This count is executed 6 times, and next time is 3 times, that is 6 by 2, that value is 3, and 3 by 2, the value is 1.5, but here it considers the integer. The next one n value is 1, so here it is 1. So 6 plus 3 plus 1, that value is 10. So here also you can see, the value, count value is 10. So this is the problem. You can calculate the time and space complexity of any particular algorithm. Next, here it is a algorithm matrix multiplication. Here also, here I equal to 0, I less than m, I plus plus. So how many times this for loop is checked? So that is m plus 1 times. M plus 1 times. Here also m plus, that is p plus 1 time, that is equal to m into how many times this inner loop is executed, m into p plus 1 times. So how many times this statement is executed? Like here m into p times this statement is executed. Now you can see the one more for loop is there. Here how many times this for loop is executed? Here it is m into p into and k plus 1 times this for loop is checking. But here this statement is executed m into p into, like here it is a k. So m into p into k, that is, for example, value is, for example, m p k is are equal, then it simplifies, it is the big of n cube. The time complexity is big of n cube. Now we can see, for example, you can see this is the one matrix A, it is m by n, that is 2 by 2 matrix. Here it is 2 by 2 matrix. So next matrix is, that is B matrix, that is n by p, that is also 2 by 2 matrix. Here the 2 by 2 matrix. For example, the values of first matrix 1 and 2 and 3 and 4, and second matrix is, for example, 5, 6 and 7 and 8. So you can multiply these two matrices. The resultant matrix is, you can see how you can multiply these two matrices, first row and second matrix column. So that is 1 into 5, this is the one time this inner loop is, this statement is executed. Next, 2 into 7, that is 14, this is the second time, and 1 into 6 plus 2 into 8, that is 16, and next 3 into 5, that is 15, next 16 to 7, that is 42. Now you can see 3 into 6, that is 18, plus 6 into 8, 48. So these are the values. So how many times this statement is executed? For example, here m value is 2, here it is p value. So second matrix column, that is also 2, and here it is k, here k, the k is, you know already, so here it is both are, that is the first matrix column and second matrix rows are equal, then only matrix multiplication is possible. So here the resultant matrix is 2 by 2 resultant matrix, that is m into p. So here is also k value is also 2, so 2 into 2 into 2, so that is 8. So 8 times this statement is executed. That's why here it is 2 times, here 2 times, here also 2 times, Here it is 2, here it is 2, here it is 2, here it is 2. Total 8 times is executed. That's why here n into p into k, that is n cube times. The n value is 2 cube, that is 8. So the time complexity of this particular algorithm depending on that size of the matrices, like here it is a big of n cube. Thank you.